Railgun, the future. A railgun is a linear motor device that typically has a weapon design and utilize electromagnetic force to fire projectiles at high speed. Normally, the projectile is free of explosives and instead relies on its high velocity, mass, and kinetic energy to cause damage. The electromagnetic effect of a current flowing down one rail into the armature and then back along the other rail accelerate a sliding armature along a pair of parallel conductors in a railgun. It was first introduced by French inventor André-Louis Octavie, creating a small working model in 1917. Two metal rails that are parallel make up a railgun. These rails are attached to an electrical power source at one end to create the gun breech end. The magnetic field inside the loop from by the length of the rails up to the position of the armature is produced by this current, which causes the railgun to function like electromagnet. This creates a Lorentz force that accelerates the bullet along the rails, always out of the loop and away from the power source, toward the muzzle end of the weapon. One benefits include projectiles being less expensive than conventional weapons, and not requiring the storage or handling of explosive propellants or warheads. Exceed 3 kilometers per second. Military weapons that use explosives cannot easily reach muzzle velocities of more than 2 kilometers per second. In the existing designs, both the friction of the projectile existing the device and the energy through the rails generate enormous amount of heat. Due to the equipment melting, lower personal safety, and enhanced infrared signature, this results in 3 main issues.